All right, guys, this video is going to cover notes 8.4. This will be day 2 of us looking at trigonometry. So just to start off, we're going to go ahead and just look at some review problems here, and we'll make some connections to what we're doing in these first 3 problems into what we're going to be doing in the notes today. So for these different examples that we have here, it's asking us to solve. If I want to solve, that means I want to get the x by itself. So if I want to get the x by itself, we cancel out a plus 4 by doing the opposite, which would be to subtract 4 on both sides. If we do that, this cancels, giving us x is equal to, well, 24 minus 4 is 20. We get x is equal to 20. If I look at the next problem here, then we're looking at 2 times x is equal to 20. If I want to cancel times 2, we do the opposite or the inverse, which is to divide by 2. So dividing by 2 gives us that x is equal to 20 divided by 2 is 10. And then lastly, if we're looking at x squared is equal to 49, the way we cancel out a squared is by doing the inverse. So the inverse would be to square root. If we square root both sides, we get that x is equal to 7. So there's kind of what we're basically doing here with the first 3 problems is we're basically solving for x by canceling items out. The way we cancel items out is by doing the opposite. Okay. So what we have down here at the bottom now, it says when solving equations to solve for x, we use the formal kind of name for this is we use inverse operations. So, for example, in the first one, when we're solving for x here in this first one, we use the inverse operation of addition. The inverse operation of addition is to subtract. In the second one, the inverse of multiplying by 2 is to divide by 2, right? So we use inverse operations to solve for x. And so we know the inverse of adding, subtracting, multiplying, dividing, etc. What we're going to look at in the notes today is the inverses of our trig functions. What is the inverse of sine, cosine, tangent, right? And just kind of as a reminder here, remember that when we're using trig, we label our sides, the hypotenuse, your opposite, and your adjacent based off of this guy, which is called theta, that represents your angle of perspective. So what we're going to look at here is what do the inverses look for sine, cosine, and tangent. So if we're looking at sine, cosine, and tangent, the inverse of sine is denoted by sine raised to the negative 1 power. This is read as sine inverse or inverse sine. Cosine works in a similar fashion. Cosine with a negative 1 is read as cosine inverse or inverse cosine. And then same thing can be said for tangent. Tangent with a negative 1 for the exponent is read as tangent inverse or inverse tangent. So what we're going to use is we're going to use these inverse trig ratios to solve our equations in example 1 and example 2. So in example 1, it says solve for x. If we're going to solve for x, let's go ahead and look at setting up an equation here. What we looked at yesterday in the notes was that whatever angle we're given here is your angle of perspective. In this case, they didn't give us the angle. They want us to find this angle, which is x. So today's notes, which you'll notice is going to be all about finding missing angles using trigonometry. So here's our angle of perspective. If we label our triangle, we're going to start with the hypotenuse. This is our hypotenuse, this is our opposite, and this is our adjacent. So if we're going to set this up, what we're currently working with here is we're working with hypotenuse and we're working with adjacent. And if we're looking at setting up our trig ratio, remember the acronym SOHCAHTOA. SOHCAHTOA will tell us which one of these trig ratios we're using. If we're looking with adjacent and hypotenuse, well, adjacent and hypotenuse is A and H, so we're working with this one, which is going to be cosine. So if we're to set up an equation here, what we're writing essentially is cosine of, in the parentheses, you put the angle of perspective. In this case, it's x. That's equal to, well, adjacent over hypotenuse. Adjacent is 10 over the hypotenuse of 11. So here's our equation, right? This is going to be a little bit different than what we looked at yesterday because now what you're going to be noticing is that your x that we're wanting to solve is trapped inside that parentheses. What I really want to cancel out here is the cosine. How do I get rid of the cosine? Well, we get rid of the cosine by doing the inverse operation. Similar to the warm-up that we did here, how did I get rid of the plus 4? We got rid of the plus 4 by doing the inverse, which is to subtract 4. So we're going to do the same thing here for cosine. The way that that's going to look here is to get rid of this cosine, to get the x by itself, we're going to have the x by itself whenever we take the inverse cosine of both sides. So we take the inverse cosine of both sides, essentially this is what's going to happen. We're taking the cosine inverse of both sides. What that does is that cosine inverse cancels out the cosine, leaving you with x. So x is equal to, well, I have 10 over 11, and we're taking the cosine inverse of that. The way that that'll be written is like this. Cosine inverse of 10 over 11. And so this at this point of our equation, we can go ahead and plug this into the calculator now. Okay. I know that this looks a little bit weird, but the idea here is that we cancel out a cosine by doing the cosine inverse of both sides. So what we're doing now is we're plugging this part into our calculator. So we're going to go to Desmos, or the yellow calculators if you're at school. Desmos is what we have here. So Desmos, we're just going to make sure that it's in degree mode. I'm going to go down here, put it in degree mode. And what we're plugging into the calculator is cosine inverse, which is the cosine -1, and then 10 over 11. So if we plug that in, let's take a look at what we get. When we plug that in, you're going to find that cosine inverse is going to be right here. Okay, so cosine inverse, and then we had 10 over 11. If we plug that in, then what you'll see here is we get this decimal right here, 24.6199773287. We're going to round to the nearest two decimal places. So if I'm going to round to the nearest two decimal places, we're going to look at the following number. That following number is 5 or more. So this 0.61 will round up to 0.62. So our value for x is 24.62. So x is approximately 24.62. And that is how we use inverse trigonometry to find missing angles. Okay, let's practice with number 2. So for number 2, let's look at what it's asking. It's asking us to find the value of theta. Let me just erase this top part here so it's not in our way. So if we're asked to find the value of theta, theta is your angle of perspective. If we're labeling our triangle, this is your hypotenuse, this is your opposite, and then here's our adjacent. What we're working with here on this one is we're working with the hypotenuse and the opposite. Hypotenuse and opposite is O and H. I see O and H right here. So that tells me we're working with sine. So if we're going to set up our equation, what we're writing here is sine of our angle of perspective, which is theta, that's what they want us to find, is equal to our sine ratio is opposite over hypotenuse. So 15 over 41. And so what we're trying to find here is the value of theta. You can think of theta as a variable, so similar to x here. So sine of theta, I want to solve for theta. The way that we're going to do that when you're solving for missing angles, you're going to use the inverse trig. So I want to get rid of this sine. The way we're going to do that for this scenario is you're going to take the inverse sine of both sides. If we do that, the sine cancels with the inverse sine, leaving you with just theta is equal to sine inverse of 15 over 41. And now we're ready to punch this into the calculator. So our theta is sine inverse of 15 over 41. So let's get that typed in. We got sine inverse of 15 over 41. So looking at what we have here, sine inverse of 15 over 41 gives us 21.46. And then if I look at the next number, if it's not 5 or more, then it stays as is. So 21.46 is our answer. So x is approximately, well, not x, I'm sorry, theta is approximately 21.46. Let me just double check I got that decimal down right here. 21.46 is correct. So that's what we're doing here for inverse trig. Okay, we're just going to practice with a few more examples. If I look at the next page in our notes, this is more or less giving you a shortcut of what it is that we're doing whenever we're solving for angles, right? So what we basically just did on the last problem is we're basically just looking at this part right here. We just took the sine inverse, right? Whatever ratio you're working with, if it's sine, you just take the sine inverse of, that ratio opposite over hypotenuse. In this number 1, what did we basically do? We were working with cosine, right? Adjacent and hypotenuse. You just take the cosine inverse of that ratio. That's really all we're doing to solve for missing angles. Okay. But let's go ahead and take a look at number three. Let's practice a little bit more. So number three says find x. Here's our x. Here's your angle of perspective. This here represents your hypotenuse. The 33 represents your opposite. So if I'm working with opposite and hypotenuse brings us to sine again. So if we're going to set up our equation like we did yesterday, our equation is going to be set up in the following way. We're looking at sine of x is equal to, well, opposite over hypotenuse would be 33 over 53. There's your equation. That's your equation that's set up. So that's the equation. What we're going to do now is we're going to solve this for x. So to solve for x, we're going to need to take the inverse sine of both sides. If we do that, these inverse sine, the sine and the inverse sine cancel out, leaving you with x is equal to, well, sine inverse of 33 over 53. And we plug that into the calculator. So sine inverse of 33 over 53. Let's see what that gives us. We got sine inverse of 33 over 53. That gives us 38.50. And if we look at the next number, it's bigger than 5. So it's going to round up to 0.50 will become 0.51. So 38.51 will be our answer. X is approximately 38.51. So this angle here, X, is 38.51 degrees approximately. All right, let's practice with number 4. It says find the measure of angle Q. Angle Q is located right here. You'll notice that angle Q doesn't have anything labeled for it, so why don't we just label this as X? If we labeled that as X, then what we're looking at here is this as our angle of perspective. And we would start with labeling the triangle, always start with the hypotenuse. Here's your hypotenuse. Across from our angle of perspective is opposite, and 42 would represent adjacent. So in this particular problem, what we're working with here is opposite and adjacent. And if we're working with opposite and adjacent tells us that we're working with tangent. Now you can go directly to what we have here. That's going to basically tell you what you're going to plug into the calculator. But let's again practice setting this up with what we've learned in the past. So if we're going to be setting this up the way that we did in the past, this would be tangent of, not theta here, but tangent of our angle, which we labeled as x, is equal to, well, tangent is opposite over adjacent, so 56 over 42. And what we want to do now is we want to solve for x. So you're going to cancel this tangent out by taking the inverse. So tangent inverse of both sides. What this does is this cancels out the tan and the tan inverse, leaving you with x is equal to, well, tangent inverse of 56 over 42. So let's plug that in and see what it gives us. So tangent inverse of 56 over 42. Let's take a look. Tangent inverse of 56 over 42. What we end up with here is approximately 53 point, we have 13. If I look at the next number, it says 0, so that is going to not round up. It's going to stay as is. 53.13 is our approximate value here. So x is approximately, I already forgot that number. Let me double check again what that was. It was 53.13. Approximately 53.13. But let's answer this in the format that it was asking. It was asking for the measure of angle Q. The measure of angle Q we labeled it as x. So the measure of angle Q is just your x value, which is 53.13. Okay, so that in a nutshell is pretty much how we solve for missing angles using trigonometry. The only other thing that we're going to look at in the notes here is what does it mean to solve a right triangle? You might see a question pop up that asks you to solve a right triangle. What it means to solve a right triangle is it means to find all unknown sides and angle measures. So to solve a right triangle means to find everything that there is to know about it. You need to know all the side lengths and all of the angle measures. So what we learned now in geometry this year is that we know that we can solve for missing sides of right triangles by using Pythagorean theorem is one way. Right? Pythagorean theorem, remember that that is your a squared plus b squared is equal to c squared. We also learned using special right triangles. This was your 45, 45, 90, 30, 60, 90. And now the new way that we've learned to find missing sides in a right triangle is by using trigonometry. Trigonometry was your sine, cosine, and tangent. Now, the other way that we want to make note of here is that we can solve for missing angles of a right triangle by using the first thing that we learned this year was the triangle angle sum theorem, which the triangle angle sum theorem I'm going to write out here to the side. The triangle angle sum theorem basically says this. If we have three angles in a triangle, the three angles in a triangle add up to 180. So that is your triangle angle sum theorem. And then the other way that we learned about today is we can solve for missing angles in a right triangle by using trigonometry, right? Specifically inverse trigonometry, right? And that inverse trigonometry is the cosine, sine, and tangent that has the little exponent of -1. So let's look at one example of solving a right triangle, and then we'll wrap up the notes for this video. So if we look at example 5, it says given triangle ABC. Let's go ahead and start labeling the picture. They could tell us that AB is 10. So AB is 10, BC is 7, angle C is 90, which is given by that right angle, says solve the right triangle. So to solve the right triangle, we need to find all the missing sides. So the first thing I would kind of focus on here is we need to solve all the missing sides and all the missing angles. I'm just going to find the missing side. Let's call this side X. If we call this side X, then we can solve for X by using trig if you wanted to, but we would need an angle first. But you can just use Pythagorean theorem. If we do Pythagorean theorem, we are doing a squared plus b squared is equal to c squared. Doing so here, we're looking at c is the hypotenuse, so that would be 10 squared for c. A squared and b squared are going to be these two guys. So we're looking at x squared plus 7 squared. If we actually start to work this out, what we're looking at now is x squared plus 7 squared is 49 is equal to 10 squared, which is 100. If we're to solve for x here, then we're going to subtract 49 on both sides. What that gives us is x squared is equal to 51 when we subtract. From here, you square root. You get that x is equal to the square root of 51. Does not give us a nice number. It gives you a decimal. If you're not sure, you could always double check in the calculator. If we type this in here, the square root of, let's do that on a different line here. Square root of 51 gives you a really long decimal. We don't want this super long decimal, and I do not want you to round either. So we're going to leave it as square root of 51. Because if you try to break it down, it doesn't break down. Okay, I think that you can probably do 3 and 17, but that's about it. So x is equal to the square root of 51. So we can say here that AC, this is the square root of 51. Okay, so we found all the missing sides. What we need to do now is find the missing angles. So if we're going to find the missing angles, why don't we take a look at finding this missing angle right here, angle A. I'm going to call angle A Y. I don't want to call it X because I already used X before. So angle Y is what we're looking at here. We're going to use that as our angle of perspective. 10 represents your hypotenuse. 7 will be the opposite. And our square root of 51 will be the adjacent. So if I want to find Y, what we're working with here is you know all of the sides, but if you have a choice, I'm probably going to use the 10 and the 7 here. I don't want to use the square root of 51. You can. These numbers just look a lot nicer to work with. So that tells me that if I choose these numbers, we're working with opposite and hypotenuse. If we look at our acronym for SOHCAHTOA, the one that deals with what we're working with opposite and hypotenuse is this one right here, sine. So if we set up an equation here, we're looking at sine of our angle of perspective, which is y. So sine of y is equal to, well, opposite over hypotenuse, 7 over 10. And we're solving for the angle, which we labeled as y. The way that we did that in the notes today was we took the inverse, in this case, the inverse sine of both sides. Doing so cancels this out, giving us y is equal to sine inverse of 7 over 10. From here, we just plug it into the calculator. We're looking at sine inverse of 7 over 10. So plugging that in real fast, we're looking at sine inverse 7 over 10. We get here approximately, in this case, we are going to want to round. We're looking at rounding to the nearest two decimal places. We have 44.42. The next number is a 7, so that tells us this 42 will round up to 43. So your angle here is approximately 44.43. So 44.43 is the approximate value for y. So that tells us angle A is approximately 4.43 degrees. Okay. So if this is approximately 44.43 degrees, we now have enough information to find angle B. Angle B, we understand that from the triangle angle sum theorem that these three angles have to add up to 180. So angle A plus angle B plus angle C has to add up to 180. That is the idea we're working with. So setting up that equation, we can plug in everything that we currently know. Angle A we found out to be 44.43. Angle B, that's what we're wanting to find. So I'm going to write this as angle B. Plus angle C. Angle C is, it's got the box there, so it's 90. It's equal to 180. If we add these two values up together, combining like terms, 44.43 plus 90 gives us 133.43. Plus angle B is equal to 90. From here, you just subtract on both sides. So if we subtract 133.43, and I just realized that I wrote this wrong. That should not be a 90. That's a 180 that we have on this side. So there we go. So when we subtract 133.43 on both sides, we now have the angle B by itself. Angle B is going to be equal to 180 minus 133.43, which I believe is 46.57, but let's double check with the calculator. 180 minus 133.43 minus 143. Let me make sure I get this decimal right here. 180 minus 133.43. So 133.43 is what we're subtracting. We do get 46.57. So 46.57 represents the value for angle B. So angle B is approximately 46.57. And there it is. We solved this right triangle. We found all of the missing sides and all the missing angles. All right, so that's going to be the end of this video.